Tell me, you buy a house. How much do you want to borrow? 50 grand only. Wow. 50 million for 50 grand to 50 million. All right. Hey, did you hear about that guy that just won 40 million at Leffington?
What?
Yeah. Was it? Leffington news agency just sold the 40 million lottery ticket to someone in here. So that's amazing, huh? Imagine that. Sorry? Someone, exactly. You just see them tomorrow with a different car, you're like, hey. All right.
You'll send them a different house.
Yeah, you wouldn't even see them here anymore. Yeah. All right. 450. Let's keep it nice and easy then. 400. I think that's fine. 400 is good. Are we happy with? Okay. So the amount we're going to buy for the house is 400,000. Just this is paper. Write this down. Whatever. Someone, can you provide paper to Miss Eden, please, if you can? Thank you. 400,000. All right. Does anyone roughly know what the current rate is if you borrow money? Roughly. 16%. Holy crap, that's high. No, that is our credit. Credit cards, probably 6%. Still high for today, but I think average, you're probably going to be right. So if we take on an average lifespan of 30 years, 6% is about right. Right now it's around 1.8, 2%, 2.5, whatever. So we'll do 6%. I think that's fair for 30 years. So rate 6%. Okay, N. Yep, N. How many years? Usually, when you borrow a house, it's 30 years. If you're able to, you pay it off in 25 years, 20 years, 15 years, 2 years, 1 year, whatever, right? But standard is 30 years. So we're going to do N equals 30 years. Now, do you know how it works? So if you right now, you go to the bank, you bought, they put 400,000, you've got this house. That's great. But what do you got to keep doing? And how often do you have to keep paying them back? Monthly, usually. They're not going to allow it. You say each year? No, yeah. Monthly, each year. Monthly, you have to pay them back. Now, do you just pay back 400,000? Well, that would be very nice of them. They need to make money. You've got to pay back 400,000 plus any interest in that month. Correct? What about the second month? Well, you pay back some money. You pay back some money though. So you shouldn't just get charged interest on the 400,000. You should get charged interest on the balance of whatever's left. Do you get that logic? What happens in the 10th month? What should happen? You should get charged interest on the balance of the 10th month. And then you're going to pay back some money. What happens after 25 years? You should get charged interest on whatever you're up to after 25 years. And then you pay some money back. Sounds good? Okay. Now, this is not dynamic, which means this is not exactly realistic in the sense where interest rate changes, your situation, your life changes. You might pay more, you might pay less, whatever the other is. This is not dynamic. This is just saying if I went and borrowed 400,000 and I knew I was going to get charged 6% for 30 years, what is the exact amount I need to pay every single month so I can finish it off after 30 years? Sounds good? That's what this is saying. So don't think that, whatever. All right. So right now we're doing a loan repayment question. So these are loan repayments. Now here's something that everyone gets stuck with because obviously the topic's part of loan repayments, and then all of a sudden I bring fish in. What? Yeah, fish. I go, hey, I've got 400,000 fish, and all of a sudden my fish are reproducing, so they're growing. But then I've got to sell some fish as well every month. I thought, can you see the logic of that is actually the same? Think about that for a second. I've got 400,000 fish to start with. They reproduce, which means they grow. But then eventually, each month, I sell. So the math is going to be 400,000, make it grow, so that's interest, and then minus my repayment. minus 2,000 fish gone. Whatever. Even though it's a different question altogether, the math works out exactly the same as what I'm about to show you. So I think the biggest hurdle students need to jump for this style of questions compared to max-min problems is that in max-min, actually, when the questions do change, the math changes slightly. Here, when the question changes, the math actually doesn't change. You're meant to not change. But when you read it, you'll be like, Sam, how do I do it now for this fish case? Or now how do I do it for this case? It's not like that. It's not like max-min problems where we change it a bit. This one, very consistent. Okay, let's see. One last thing. N is generally the amount remaining. Amount remaining. After N years. After N, we're going to call it months, actually. This is compounded, as you guys said, monthly. All right, as it usually is. What's the only thing that's compounded daily? The rate you said before, and I said, yeah, credit card. Credit cards are compounded daily. You get charged every day.
I thought it was monthly.
In fact, sorry?
I thought it was monthly as well.
No, always you wish. They get money, because it's a small amount. They've got to do it every day. In fact, if you buy something today on a credit card, it's important that people know this because a lot of people who do this don't know this. If you buy something today, it's charged from today. So therefore, technically, if you buy something today for $1,000, that means you get charged on today and tomorrow, by the time it's tomorrow. A lot of people think, oh, that's only been 1 day. So they might call up the banks or whatever and say, oh, it's only been 1 day. It hasn't. It's been 2 days. So you're charged on 2 days. You got to think of it like that. So as soon as you buy it, it starts on that day. Doesn't matter if you bought it at 11:59 p.m. at night, it's still for that day. Not the next day yet. That's dirty, but it's business. Now, A1. A1 would be the amount remaining after 1 month. Tell me, you've gone, you're in your new house, you're living the life, you're like, yep, I've got a pool in the back, everything's happy. But what's happening? What do you see when you look at your phone? Yeah, you see a bill, and how much? What would be the amount remaining after the first month?
How much exactly?
Well, we don't know. That's what we're trying to work out.
The original price plus the interest?
Yeah, that's better. So it's going to be 400,000. And then the way we plus interest, instead of doing it as this, which is what your head would say, plus interest, we don't know what the interest is, but we know that interest grows compounded at monthly. So 1 plus 6% over 12. Remember that formula? A equals P bracket 1 plus R to the power of N. And then what happens at the end of that month? What happens at the end of that month? Remember, it's the amount. Say it again. You have to pay off something. No, you don't pay the whole thing off, you pay something. So minus, let's call it M. Again, stop, think about that again. Before that month, you were house hunting, you found the house, sweet. You signed the papers, you've got a $400,000 loan, no problems. Which means January 1st, you look at your account, it says 400,000. January 30th would say 400,000 and 403,000 you might be, right? So interest got charged already straight away. On the 31st, you pay back some money. You might pay back 2,000, 3,000, 4,000, 5,000. So that's what you'll see. In your account, you actually see 400,000 with the interest and then minus the amount of money you paid back. Do we agree with that? 100%, because that's pretty much what I need to see all the time. A1. The only thing is we don't write whatever I wrote here, 1 plus 6% over 12. We usually write it as 1.05. No, wait, 6% divided by 12?
0.
Yeah, I thought so. Thank you. Minus M. Let me know if you get super again. Okay. What happens in the second month?
A1.
A1. That makes sense, right? The amount, what you're going to see in the second month is the amount that you just had from A1, the amount that was remaining. And then what's going to happen to A1? That's got to grow. You're going to get charged interest. What's my growth amount? 1.005. And then what do I do on that, on the last day of the month? Minus M. I got to pay back some money. Are we sure? We get the logic? Good. And then you're meant to technically sub in A1 into here, but I think that just complicates it sometimes. Just, can we say that it's just going to be this whole thing multiplied by this bracket? So then that's going to be power of 2, that's going to be power of 1, and then I still have a minus M. So let me know if you agree with my next line. Ready? Technically, I'm not subbing it in. I just know what's going to happen. So that's squared. That's minus M, 1.005, and then minus M. Just take your time. See if you agree with that. I might highlight. That is that. And we're multiplying it by this term in orange. So it's squared minus M minus M. Happy? We generally do it 3 times. So then, what's going to be A3? What does A3 mean again? Say better. You said third month. Amounts remaining after 3 months. Good. A3. Without doing the math. I'll do it firstly. We'll just do it. A2, 1.005 minus M. And then go. What's your answer for A3? Just from looking at your last line in A2. 400,000 to the power of 3 minus M to the power of minus M to the power of, and then minus. Oh, good. If you don't think you're there, then just do it slowly. You can see that times that becomes power of 3. That times that becomes power of 2. That times that becomes power of 1, and you still have a minus M at the end. Absolutely will be in your exam. Exactly like this. Remember, don't forget. It's not like it's going to be anything different. It'll be this. So it's either you study it, you do well, you don't get marks for it. We don't write them in decreasing powers. We don't write them in decreasing powers. So we don't write 2, 1, 0. I don't like that. But you're always going to have that. So your next line is, we're going to flip it around to make it increasing in powers. So it's going to look like this. Equals 400. Oh, you don't touch the 400. That one's not in my series. Because my series is going to be with my M's only. 1.005 to the power of 3. This is the one that flips. Minus M, minus M, minus M. So now we've got power of technically 0, power of 1, power of 2, and it keeps going. Just so we know we're doing this right. You don't need any more, but I'm going to do power of 4. What's the answer for power of 4? 400. But just make a note there and say you don't need power of 4. Minus 4, minus M, minus M, minus M, minus M to the power of what? What's my last one? 3. It's very important that you know what your powers of your last term are going to be. Katie, what do you reckon? Agree? Confused?
I'm just processing.
Processing, tell me. Tell me what part.
Oh, no, as in...
Yeah, I know. But do you feel like if you were to do this yourself, just by looking at it, I know you're accepting it right now.
Mm-hmm.
When you're looking at it, you're like, okay, yeah, you rearrange there. Power of, like I said, 4s you don't need. But if I go back to A3, I did A2, then I expanded, then I rearranged. You feel like roughly you can execute it?
Yeah.
Roughly. That's good. That's okay. What about you, miss?
The rearranging part, I'm kind of confused.
Your teacher didn't do it?
You just covered it.
Oh, sure. Okay, the rearranging part, I'm confused. All I've done is just put the minus m at the front. This one in the middle, this one at the end. The only reason why we are rearranging it, in your series, this would have been your first term. Whereas now, my first term is actually going to be this, which is a lot nicer. You'll realize why in a second. Cool? So all you want to remember is don't use it decreasing. You always want to use it increasing. That's all you got to remember. Okay. Now, we are going to go to A to the A of what? Well, N technically not, because we know how many years we're doing it. But if 30 years, 30 times 12, 360. So we're doing it for 360 months. Give me your answer. Giovanni, what do you reckon? Equals?
400,000.
400,000.
Bracket 1.005 to the power of 360.
Hold on, wait for me. 5 to the power of 360 minus m, 1.005 minus m, 1.005 squared, dot, minus m, 1.005 to the power of 359. Why? Because when it was a 3, it was a 2. When it was a 4, it was a 3. So therefore it's 360 becomes 1 less, which is 359. Whereas when this was a 3, this was a 3. When this was a 4, this was a 4. When this is 360, this is 360. So that's why those are the same. You get that? Do you see why we increase now? Because otherwise, if your last one, if you had a decreasing, your last one would have still been a 1. So weird. It's confusing. That's why we actually rearranged and make it from increasing. All right, sweet. Now, we're very close.
We're going to work even with that.
Would it work? Yes. Does anyone in the world do it or not? So don't do it because you're going to confuse. You're so confused with your series, like I said. We haven't even done the series part yet. We've just been doing just algebra, really, at this point. Equals 400,000. 1.005 to the power of 360. Okay, what do you see is common? By the way, this is our series, right? I gotta keep saying this. This bit here is our series. Why is that our series? Because that's the only thing that has a common ratio that's getting multiplied. Whereas the part on the left, it's not a series, it's just a term. All right, what can I factorize out from all of that that's in orange? Minus m. Minus m. What are you left with? 1 plus, because I took out a minus, plus, yeah, good, done, plus, plus, what the hell? Still good? Next line, we actually have a series now. This is a series. This is a series. What does A equal to? A is your very first term. 1. What does R equal to? R is your common ratio that it is being multiplied by. 1.005. What does n equal to? N is equal to the number of terms you have. Just wait before you take a guess. Because everyone just shouts out 359, 360, 361, just wait. Think about it. Think here, just here they are. Think of all these numbers you would have had. How many terms will you have? Okay, well, if I start from here, yeah, if I start from here, that's 1. From here, 1, 2, 3, 4, 5, 359. So all of that is 359. Plus one more, 360. There's actually 360. Tomorrow's question, we might see another question that says this. How many are there now? 359. You can't just make guesses. You've got to just look. How many are there actually? But there, in this case, it's 360. Don't choose n equals 360 just because we're doing 360 months. Let's just for now say it's coincidental. Because it's not going to be happening every case. Good. Now, back to it. Does anyone remember the summation formula for a geometric series? Sn equals, anyone remember it? A, bracket.
1 plus r plus 1.
Say again?
I was going to say 1
Yes.
plus r.
1 plus r, no. R1 minus r or r minus 1.
Oh.
So A bracket Rn minus 1 over r minus 1. Okay, we are super close now. A360 equals 400,000. 1.005 to the power of 360 minus m a, which is 1, times r to the power of n minus 1 over r minus 1. We're getting very close to just being calculator work now. Okay, how many letters am I missing now at that last line? How many letters am I missing? 2. I'm missing the A and I'm missing the M. You got to be aware of that. I'm missing 2 letters. If I'm missing 2 letters, obviously to solve for one or the other, one's got to go. What does the amount equal to after 360 months? Why? You paid it off after 30 years, remember? The amount is equal to 0. So that number is equal to 0. I'm going to bring everything to one side. So essentially you have 400,000. That's 40,000, isn't it? 400,000. 1.005 to the 360 must equal to m. And then I'm not going to really rewrite that again. I'm just going to write answer because you would have plugged that into your calculator. And we're going to divide. So m equals b, and let's call this a, b over a. That's how most of my students just remember it. It's just going to be b over the a. So